Hello, so we have another number 24 from AMC 12B. So let's see what we have. So ABC is a triangle, M is the midpoint of AC, CN is the angle bisector of ACB, and N is NIB, and X is the intersection of the median BM and bisector CN, and B and X is a quadratic triangle with AC is given 2, and we want BX squared. Okay, let's start with some sketch just to see how things looks like. I'm going to try drawing this kind of first, and then if I need to adjust, I will do that. So let's say this is A, this is B, and this is C. So it says AC is the median. Okay, so that looks like this. And then CN will be angle bisector. So you will get C and something like this. And then BXN, so the X is the intersection. So this guy is equal to triangle. It doesn't look like a triangle in my diagram, so maybe I will adjust a bit. And then AC is 2, since this is midpoint, so that should be 1 and 1. So, I want to get this angle somehow reasonable, like for 60, it looks like a bit bigger than 90. So I will just make this AC a bit bigger. So let's draw this again. Because this is going to be usually better to kind of draw anything that looks, give you some idea, and then adjust your diagram with the other information you actually get. So that is usually helpful. Okay, so again, this is going to be not too great, but it is slightly better than the first diagram I start with. So the ABC. And then we have BB to the midpoint of AC. And then I will have, yeah, this is not really too different, but anyway, so I'm going to just deal with that. So this is going to be M, and then this is N. And we know these are 60s. Okay, and then that will be 1, and that will be 1. And this is the vertical angle, that should be 60, and then this is like 120, and then this is 120. And what else do we know? Since this was angle, like CN is angle bisector, I'm going to call these guys, let's say, those names. We can even name like alpha and whatever. And AC is 2, that's good. And then this was a triangle, and we want to get, this is X, BX squared. Okay, so it's kind of harder to see what's going to happen, but let's label a bit. So I will say this is K, and then this will be K, and then this will be K as well. So like there are a couple things I will probably look for. One is, since we have some angles are equal, which is like angle bisector, and that might be like useful to remember the angle bisector theorem. So that is something we may use. Another thing, we have like 120 or 60, which is going to be like good angles in terms of using some trick. So maybe like log cosine and maybe log sine might be helpful, or special right triangles anyway. But since we don't have much numbers involved, maybe we should label and maybe write something that will give us some sort of ratios, maybe because of the similar triangles. So one thing I'll see, like, if I label this is alpha, okay, so in this triangle BXC, I have 120 and alpha, right? And then this is the third angle. But in A and C, we also have 120 and alpha, which means angle A, and this guy has to be the same. So maybe I should write that as our first similar triangle. So just to kind of make sure we are on the same page, I'm going to draw those separately. So let's say this is AN. Okay, so that was my A and C, and then I said BXC. So let's try that as well. Okay. So the A and then this is C, and then this will be BXC. So in this triangle, the C is the angle alpha. So this is the alpha. And then X right here is 120. And then in this triangle, A and C, so the N is 120. And then the C is the 1 alpha. So that's why these two triangles are similar. Angle A and angle B are corresponding angles. So let's write the ratios. But before we do, let's write the numbers as well. So AC is 2. And what else do we know? We have BX is, let's say, this is K. And then XC is, we do not know. And C is, we do not know that either. Okay, so, but I'm going to write the ratios anyway. So let's go with the first one. Maybe I start with let's do triangle because the K is right here. So I'm going to go with BC first. And then that's opposite to 120. So the 120 is opposite to 2. So that's BBC over 2. And then in this triangle, alpha is opposite to K. And then alpha in this triangle was right here. So that's opposite to AN. So the AN is like this one. So let's write that. And in this triangle, the third side is XC, right? Which is opposite to B. So that's opposite to NC. Okay, so that is something. But it does not look like we have much right now since we don't have anything on this triangle, but I just tried it anyway. So another thing I can look for, maybe, in the largest triangle, we have 2 alpha. Like another way of saying, like I'm just gonna say like ABC, like A and C, we said this is 120, and then this is alpha, that means angle A was something, the third angle in that triangle. So with that, like if you look at the BMC, that's also having the same angles. Why is that? Because C is 2 alpha, same as C, that's the common angle. And then this angle right here, M, is basically the angle that supplements 60 and alpha. So which is like, if I know this is, let's say, beta, okay, so if I call this is beta, so the beta alpha 60 is 180 in this triangle, So that's beta, but beta is like basically 120 minus alpha. And if you look at this triangle, so we have beta and 2 alpha, and this is the third angle. And if I look at the largest one, so we have 2 alpha, and then this is something, and then this is going to be another angle. So like what I'm trying to say, in A and C, we have alpha and 120, right? So and this angle is the angle that is going to be 60 minus alpha if I really want to label that way. So 60 minus alpha, because 120 plus alpha plus this has to be 180. Okay, so then if I want to say the beta, maybe I should write that. So the beta is equal to sum of this angle and this guy, which is like 120 minus alpha, because beta is exterior angle. So maybe I should write this in terms of alpha, which is 120 minus alpha. So I just want to write some angles in terms of the other one, so we can kind of see if there's something else we can see as similar triangles or even congruent. So we have 120 minus alpha for this one, because this is plus this is my 2 interior, so that will be exterior. So 120 minus alpha. So, but now we have 2 alpha, and then when you add with this, you got 120 plus alpha. So that means this guy should be 60 minus alpha. So I hope that makes sense. So if you don't, just make sure you add the angles and see if that's up to 180. So the reason I'm saying this, because this angle right now, B, is the same as angle alpha, which we kind of have in this diagram anyway. So we said the third angle right here, B, was this guy, but we were using this smaller triangle. But now I'm going to use this larger one, because B is the same as A. So that was something we already have, but I just showed another way of seeing that was actually the case. So let's draw those 2 triangles again, just to kind of see the similarity. So we have like this ABC, and then we have a little bit longer diagram for the one. These are not accurate, but I'm just showing to see their corresponding sides and angles. So the ABC, and then there will be B, M, and C. So this was 2 alpha, and then this was 2 alpha, and then angle M was 120 minus alpha, which is this guy. In the largest one, angle B is the 120 minus alpha, so M and B are congruent. And then A was 60 minus alpha, so I'm gonna maybe just label it that way, and that corresponds to the B, so that should be corresponding angles. Okay, so what we know in this case, MC is 1. Okay, BC we do not still know, and then this was the K, and BX we do not know, but BM is like this entire thing, which we do not know that either. Okay, so, and then what else do we know? BX not known. Okay, so let's write the ratios anyway. So in this case, I'm gonna start with AB, which is K. Okay, I'll say, let's write AB first. AB is opposite to alpha is opposite to BM. Okay, and that is, let's go with the BC. BC is opposite this angle. The same angle was this. Oh, I just write those wrong, right? So let me put this. So the angle B was equal to this one, right? Okay, so then MC was 1. So let's write the ratio. So AB is opposite to alpha is opposite to BM, and is equal to, let's go with BC now. That's opposite this angle, which is opposite to 1. And the third angle in the side in this triangle is AC, which is opposite this angle. This angle is opposite BC, so you'll get BC. So from here, so you can see like AC was 2, so you can replace that 2. And then when you do cross multiplication, so BC squared is 2, so the BC is root 2. Okay, this is something nicer because we have now a concrete numbers that we didn't have before. So that means this is root 2. Okay, so then let's see how this might be useful. So we got the, like first thing first, like we are looking for the K squared. We just don't really probably need the K itself. So, but how this is going to be useful? So we have the XC right here and NX right here, right? So maybe I can write the ratios right here. So since we know the BC is root 2, I can plug by right here. So let's go ahead and do that. So root 2 over 2. And this is equal to, so in this case, XC is this one. I don't know about that one, but let me write and like CX, right? CX, I'm going to say, okay, CX over the NC. NC is the entire thing, which is K plus that. So let's go ahead and write that. So K plus CX. And if I can write maybe CX in terms of K, that might be useful. So because when you know this triangle, like this side is K and then this side is known. So if I can write this guy in terms of the K, then I can use log cosine because we have angle in between. So let's do that. So you will get the K times root 2 plus CX times root 2 equals 2CX. If I pull this CX together, so you will get CX times like 2 minus this number, so which will be 2 minus root 2 equals K times root 2. So what I just did basically, I subtract this from both sides, and then I pull the CX as a factor, so you will get CX now as K times root 2 over 2 minus root 2. Like you can multiply this by 2 plus root 2, right? So that should give us 4 minus 2 for the bottom, which is 2. So and then when you multiply the numerator, so you will get K times 2 root 2 plus 2. And when you divide by 2, you will get root 2 plus 1. Okay, so the CX is now known, so which is this guy. So now I can use log cosine with using this triangle. So let's do that. So if I wanna start with the, let's say A squared equals B squared minus I mean, plus b c squared, right? C squared minus 2 times a times, I mean, I just need to, the 2 times b times c times cosine alpha. So that's the log cosine. So in this case, I'm going to start with this guy, which is going to be root 2 squared will be 2. And then b, I can take this as b squared. And then this will be cx, which is this number. So if I square, so you get root k squared times square of this will be, when you square this one, you get 3 plus 2 root 2 square binomial just used. And then minus 2 times b, which is k times root 2 plus 1. And then cosine 120 is -1/2. If you just remember the unit circle, you can just go with that. If you don't, you just maybe write triangle, and that will help out. But anyway, so that should be 2. And we just kind of have to simplify this a bit. So you get like 3k squared plus 1, that's 4. When you multiply this, this is negative, that will become positive. So you got k squared times 1, which is 2k squared, but 3 more. And then 1 more, so it looks like 6k squared. And then we got 2 root 2k squared. And then root 2 times 2, that will be another 2. So it looks like we will get, let me see, a 2. And then you got, actually these 2's will cancel, like this 2 and this 2 was actually going to be canceled. So you got only 5, right? So this will be 5. Okay, so the 5k squared, because 1 from here, so and then 3 from here, and then 1 from here, because k squared times 1. So that's 5. And then 2 root 2 times k squared, just there's 2 root 2k squared, but there's 1 more, so that should be 3 root 2 k squared. Okay, so then if I just want to divide by k squared, I mean, pull the k squared as a common factor, so the k squared is going to be equal to 2 over 5 plus 3 root 2. And I can multiply this by 5 minus 3 root 2, 5 minus 3 root 2, to kind of remove that denominator from irrational. So that will be 25 minus 18, which is 7. And if you multiply the numerator, so you got 10 minus 6 root 2 over 7. I think that is choice A. Yeah, this was a bit challenging question, but I think just starting with some labeling angles, that is actually helpful. So we kind of was like we're able to get 2 different pairs of triangles that were similar. So when you don't really see me anything, I will say just go and write the ratios and then see if there's something you can use. So from the second one, we were able to get BC, and then we just plug back to the first one to get something. But you don't want to try all the options. We just want to look at the diagram and see what is actually you just need in terms of something else. We can maybe utilize the given angles. But another thing I could have done basically in this triangle, because we have 60s, right? So we can maybe drop the alpha from B to and C. If you do that, like that will be right in the middle. And then you can say this is K and like K over 2, K over 2. You can use the Pythagorean in this triangle. You get the hypotenuse, which is you can use 36 as well. And then as soon as you have that, so you can use the Pythagorean in the other triangle as well to get the other leg. So that would be giving us XC without really using log cosine. So when you do that, so the rest will be actually no, you can still use this one, but you can just get the XC without really using similar triangles. So that's basically what I said for the second part. Okay, so I could have used the one similar triangle to get BC, and then use the Pythagorean to get XC in terms of the K, and then that could be log cosine again useful if I just Pythagorean involve. Okay, but anyway, so I'll see you in the next video.